Hello everyone. Today we'll be doing the exercise 4.3. In this 4.3 we are going to have how many questions will be there? 4 questions will be there. Okay, and question number 1 you are going to do in the book, because question number 1 is regarding the true and false, and you are going to do this question in the book. And question number 2, 3 and 4 you are going to do in the notebooks. So before starting with question number 1, 2 or 3, let us do this question number 4, because this is one word and you can easily test your knowledge with this. Now what is question number 4? Question number 4 is, write a number between 100 to 200 which is now divisible by 5 but not by 10. Okay, so what they are saying is you have to take the numbers between 100 to 200. Number cannot be 100, number cannot be 200. It has to start from 101, and or you can take 199 also. So between these numbers you have to take a number. Now what kind of number? You have to take a number which is divisible by 5 but not by 10. For this you should know the divisibility rule of 5 and 10. For 5 you know that the last digit should be either 0 or 5. And for 10 you know that the last digit should be of 0. So I am going to take a number which is divisible by 5. And if it is divisible by 5, it should not be divisible by 10. So you can take any number whose ones digit is not 0 but ones digit should be 5. So I am going to take 165. I can take 175. I can take 155. Any number you can take out of these. You can take 195, 105. Any number you can take. Right, but they are asking only one, so let us take any number you can take. 195 I have taken. Right, next B part, divisible by 3 but not by 5, 9, 10. Now for this again you should know the divisibility rule of 3, 5, 9 and 10. Now for 3 you should know that the sum of the digits should be 3. 5, again I have just told, for 5 last digit should be 0 and 5. For 10 last digit should be 0. For 9 sum of the digits should be divisible. Sum of the digits should be divisible. And for 3 also the same concept is there. Now I have taken 108. Let us suppose I have taken 108. See, this 108 is not divisible by 5 because here 5 is not there. So for this it is correct. For 10, since 0 is not there, so that means this is also correct. 9, the sum of the digits is, what is 1 plus 0 plus 8? It is going to give me 9, but 9 is divisible by 9. So now that means I cannot take this number. This number is going on the table of 3, but I should take the number which is going on the table of 3 but not on 9. So I am going to take some other number. Let it be 102. 1 plus 0 plus 2 is equals to 3. Now you can see that 3 is divisible by 3. Okay, so that means this number is correct. Is this 3 divisible by 9? It is not divisible by 9. So that means 102 is the correct option, or this is the correct number. C part, you have to take a number which is divisible by 2, 3, 5, 10 but not by 9. You have to take any number you have to take. See, for 2, ones place should be 0, 2, 4, 6 and 8. This is for 2. For 5, ones place should be 0 or 5. For 10, it should be 0. And for 3, sum of the digits should be divisible. Sum of digits should be divisible by 3. Now they are saying you have to take such a number that it is divisible by 3, 2, 5 and 10 but not with 9. It should not be there. So I have taken 150. Why? Because factor, if I am going to multiply this 3 and 5, it is going to give me 15, right? I have just taken the factors, or you can take any other number by your choice. I have taken it simply because of the factors. Now let us check whether this is satisfying these conditions or not. Last number is 0, so yes, divisible by 2. Last number is 0 or 5, it should be for 5, so yes, it is there. This is also correct. Last number should be 0, so yes, it is correct. Sum should be divisible by 3. What is 5 plus 1 plus 0? 6, and yes, it is divisible by 3. So that means this is also correct. Now the sum of the digits is 6, and is 6 divisible by 9? No. So that means this is also correct. Okay. So the answer of this is 150. So this was your question number 4. Pause the video to note it down. Now, let's do question number 2. Question number 1 I am going to do, or I am going to explain you in the last. Firstly, we are going to do question number 2 and then we are going to do question number 3. Okay. Now question 2 is find without actual calculation or actual division whether 640650 is divisible by 15 or not. See, they are saying 640650 is the number and you don't have to do this calculation. No. You just have to tell without calculation whether this number is divisible by 15 or not. See, any number is divisible with the given number if it is divisible by its factors. Now, if I am going to factorize 15, 3 5s are 15, 5 1s are 5. So, 3 and 5 are the factors. This means if this number 640650 is divisible by 3 and 5 both, then it is going to be divisible by 15 also. Okay. Now for this 640650, let us firstly check with 3. Divisibility rule of 3. What is the divisibility rule of 3? Sum of the digits. What is the sum of the digits? 6 plus 4 plus 0, 6 plus 5 plus 0. 10, 16, 21. 21 is going on the table of 3. Yes, it is going. So that means this number is divisible by 3. Next is 5. For 5, one's place should be either 0 or 5 and one's place is 0. So that means it is going on the table of 5 also. Now the given number is going on 3 and 5, which are the factors of 15. So if the number is going on 3 and 5, that means it is going on 15 also. So that's how we have done without doing the actual division. Only and only check whether the given number is going on its factors or not. If it is not going, then that means the number is not divisible by the given number also. Now let us see the solution, how we have written here. See, I have written here the factors of 15. What are the factors of 15? 3 5s are, 5 1s are. So what are the factors? 3 into 5. Written. Now divisibility by 3. Sum of all the digits 21, and I am going to write 21 is divisible by 3. Therefore 640650 is also divisible by 3. Okay. Next, let us check by 5. Since at one's place digit is 0 of 640650, digit at the one's place is 0, hence the given number is divisible by 5. Okay. Now 640650 is divisible by both 3 and 5, which are the factors of 15. So therefore 640650 is divisible by 15 also. Okay. So you can pause the video to note it down. First page and then the next page. Easy, I guess. Now let's move to question number 3. Question 3 is also easy. It's just testing your knowledge regarding the factors and the divisibility rules. A number 48 is divisible by two different numbers, say 4 and 2. They are saying that 48 is the number which is divisible by the table 4 also, and it is going on the table of 2 also. Is the number 48 also divisible by the product of 4 and 2? Okay. Now what is the meaning of the question till here? We are having a number 42. They are saying that this 48. Now this is divisible by 8 also, 4 also, and this is divisible by 2 also. If I am going to multiply 4 and 2, what will come? 8. You have to tell whether this 48 is going on 8 or not. Yes, it is going. Okay. Is the number 48 also divisible by the product of 4 and 2? That is 8. So you are going to write yes, 48 is divisible by the product of 4 and 2, which is 8. Till here done. Is this case true for other numbers? Justify your answer with explanation. Now you have to tell that they have given you 4 and 2, one example. You have to tell whether the same procedure is applicable for the other also. You are going to write not necessarily. It is not necessary that it is applying on every other number. For example, let us take, instead of 48, we are going to take an example. For example, I have taken 64. Now this 24. Now this 24 is divisible by 2 also, and this is divisible by 8 also, right? Because 2 12s are 24 and 8 3s are 24. Now let us do the product of these two numbers. What is 2 8s are 16. What is coming? 16 is coming. Just tell me, is this 24 going on the table of 16? No. So that means this is not necessary that it has to be. This case is true for every other number. We have just given an example for saying no. Example is 24. 24 is divisible by 2 and by 8. But the product of 2 and 8 is 16, and 24 is not divisible by 16. Okay, this is the example which we have given by ourselves just to prove that this is no. Okay, so this was your question number 3. Now let's move to question number 1. Question number 1 is, all these true false are there, 3 parts are there. Let us see to it. All the numbers which are divisible by 9 are not necessarily divisible by 3. This is false, completely false. Now we have done this factor 1 question. What are the factors of 3 and 3? 9, it is 3 and 3. What are the factors of 9? 3 and 3. So that means if a number has to be divisible by 9, it has to be divisible by 3. So, and they are saying all the numbers which are divisible by 9 are not necessarily divisible by 3. So false. Okay, I have given you this factor theory that the number should, if a number is divisible by 9, then the number should be divisible by its factors also. It has to be divisible by 3, then only it will be divisible by 9. Next, if a number is divisible by 2 and 5, then it is also divisible by its sum, which is 7. They are saying a number is divisible by 2 and 5. A number is divisible by 2 and 5. Let us take 10. Okay, because this number is going on the table of 2 also, and this is going on the table of 7 also. Now if I'm is going on the table of 5 also. If I'm going to add them, 5 plus 2 will give you 7. Now is this 10 going on the table of 7? No. So that means it is false. If a number is divisible by 2 and 5, then it is not necessary that it has to be divisible by its sum. Okay, I have just given an example why it is false. Take an example of 10. 10 is going on 2 and 5. Separately they are going. But if I am going to add them, it is going to give me 7. And 10 is not going on the table of 7. So this is false. The sum of, C part is, the sum of any two odd numbers is always divisible by all even numbers. It is false. Okay, now let us take all the even numbers. They are saying the sum of any two odd numbers. Let us take 3 and 7. These two are the odd numbers. Okay, and you should know what are the even numbers. Even numbers are numbers whose ones place will be, the numbers at the ones place should be 0, 2, 4, 6 and 8. Numbers which are ending with these numbers are the even numbers. Okay, now a number of the sum of any two odd numbers. Let us take 3 or 7, any odd numbers, and let us do the addition of these two, which will give 10. Is always divisible by all the even numbers. Okay, let us see. It is going on 0. Yes. 10 is divisible by 2. Yes. Is 10 divisible by 4? No. 10 is not going on the table of 4. 10 is going on the table of 6? No. 10 is going on the table of 8? No. So that means it is also false. Right? And this was your exercise 4.3. Complete this exercise in your notebook. You have to do question number 1 in the book, and 2, 3, 4 question you have to do in the notebooks. Thank you.